Welcome to our new lecture of crystallography and mineralogy. We will be talking today about crystal symmetry. And crystals and subsequently minerals have an ordered internal arrangement of atoms which will create a specific types of symmetry when we rotate those crystals. So this ordered arrangement shows symmetry, which means is atoms are arranged in symmetrical fashion and a three-dimensional network called lattice. So when do we say this crystal has symmetry? The crystal will have symmetry when one shape becomes exactly like another if you flip or slide or turn it. Once you have one of those movements and you see this shape or this face is repeating itself again, so you can say that we have symmetry. Okay, but symmetry here, you just can imagine a small two-dimensional crystal composed of atoms in an ordered internal arrangement, as you see below. And when you rotate this shape 90 degrees every time, you will see this gray point is moving from one corner to another. So if you start from left to right, and we have how many rotations now? 1, 2, 3, 4. And you can see this gray point repeating itself 4 times. So although all of the atoms in this lattice are the same, one of them is gray so that the position can be tracked. We are tracking this point now, and the crystal, if we rotate it by 90 degrees, we will notice that it will look exactly the same at what we start as we started from the original point. So rotating in one complete rotation of 360 degrees, you will see this point is repeating itself 4 times. We thus say that this object has four-fold rotational symmetry. Four-fold rotational. So there are 4 elements of symmetry. We can say about crystals. The first one is called axis, and the plural is axis of symmetry, plane of symmetry, center of symmetry, and roto-inversion symmetry. So let's talk about the first 3, which are very important to us here. These symmetry elements may or may not, maybe or may not be combined in one same crystal. We will find that one crystal class of the system has only one of these elements, and some class systems have 2 elements or 3 elements. So if an object can be rotated about an axis and repeat itself every 90 degrees, we call it four-fold rotational symmetry. And the rotation on which the symmetry is happening, we call it rotation axis. So along which the rotation is performed is an element of symmetry referred to as rotation axis. As you can see, this cube of smiling face rotating, so it repeats itself 4 times. But when rotation repeats every 60 degrees, then here the symmetry is hexagonal, and we express that as a filled hexagonal symbol, as you will see in the figure. Same thing with trigonal symmetry, but with different degrees. Here we have 120 degrees. And if it repeats itself only 2 times, So it happens every 180 degrees. We call it binary symmetry, and we express that as a filled oval is noted on the rotational axis. So every rotational axis, we express that rotational axis by a filled shape, square, hexagonal, tetragonal, binary, and it has to be filled to express the rotational axis. But because if it is not filled, then we can call it inversion axis, which is not in our scope of study here. When rotation repeats every 360 degrees, it means repeated itself one times. Some people they call it it's a single symmetry, but mostly we call, if you really want to know the truth, this means no symmetry. The following types of rotational symmetry are possible in crystals: one-fold rotation axis, and we knew about that. This is expression. And two-fold rotational axis, and you have the rotation, the complete rotation of anything is 360 degrees. You divide that by 180, it gives you the number of the axis, so it's twofold. And note that these examples, the axes we are referring to are imaginary lines. They are imaginary lines inside the crystal. They are not real, that extend toward you perpendicular to the page or the blackboard. The oval shape, we knew about that, it's twofold, as you can see. Same thing for the trigonal. Here, this is the example. And also for the tetragonal, it's just a filled square. Same thing for hexagonal. So just a thing. Okay. So now, what any two-dimensional surface that when passed through a center of crystal divided into two symmetrical parts. Symmetrical parts, like exactly like if you stand in front of a mirror. If you like you see this shape, the one on the left, this is symmetric because the line in the middle cuts this shape to exactly two parts. One of them is a mirror to the other, but the other one on the right side is asymmetric, which we cannot consider this line is a symmetric plane or plane of. So it's a mirror symmetry operation is an imaginary operation that can be performed to reproduce the object. Okay, we symbolize the mirror plane by letter M. Before we symbolize, the axis of rotations by either square or hexagonal or tetragonal shape felt. And you can see here in this rectangle, you see two planes, one from north to south and the other one from east to west. It's cutting this rectangle. Can you extract any other planes of symmetry here? No, the diagonal one is not a plane of symmetry because it will create different angles. Okay, so we have to be very careful about that. Same. And actually, this is a very nice shape figure that shows the symmetry of the crystals in cubic system, and all these are planes of symmetry, which they are, 9 planes of symmetry. Thank you very much, and see you next. We will continue talking about crystal symmetry in next lecture. Bye.